Great to see you. Thanks for taking out your time on Saturday and joining us for this TimesPro AI COE webinar. And thanks for everyone taking out your time and joining. And today, let me quickly introduce our guest. So his name is Sagar Thavda. Sagar, thank you once again. And currently, Sagar is working as a director of data science and NLP. And today we have a topic on how large language models are shaping the future. So Sagar is an expert in NLP and he has more than 10 plus of year work experience. And from past 5 years, Sagar has been actively working into AI and NLP. And currently Sagar is working at Invent Health India Limited. And I just would like to take a few minutes to just tell about Sagar's overall journey and some of his key notable projects in the field of AI in healthcare. So first of all, Sagar has also he also designed the healthcare document classifier system that separated valid documents from invalid ones for processing. And also he has also created in human in the loop pipeline, which made the ML model smarter with every batch of document processed, and also created an AI system that automated the end-to-end process of certain documents for pre-claim stages where there was zero human intervention was required. And also Sagar also created a private ChatGPT prototype for the payments firm, basically that was helping new existing clients and also understand the entire process and product of their organization. So I'll not take much time. I'll hand it over to Sagar. He's the right person who can also give you more context about his personal journey and also some of the whatever he have worked in his towards data science and NLP side, and also some insight about his project. Yeah, Sagar, over to you.
Thank you, Vimlesh. Let me share my screen. Guys, is the screen visible to everyone?
Yes, yes.
Yeah. Okay, great. All right, so today we are going to be exploring about LLMs and also understand a bit about how it is going to shape the future. Now, the thing is that future is not too distant. The future is pretty close and we are almost there. The kinds of things that LLMs have helped us achieve, it is beyond imagination. We never thought 4 years ago that we'd be able to reach this stage so quickly. But there is a lot of room for improvement, and we'll also discuss a bit about that. So without any further ado, let's get started. So Vimlesh has already given a very nice introduction about me. I really wouldn't want to talk a lot more about myself. You guys can connect with me on LinkedIn anytime. But yes, I'm currently working as a director of data science and NLP in Invent Health. And Invent Health is into risk adjustment, and we are working on some very interesting projects for our clients that is helping them optimize their overall coding and the medications related workflow. So these 4 boxes that you see at the bottom, these are some of the use cases related to NLP that are active. Some of them are in production, some of them are in the prototyping stage. And when I get into more details about it, we'll discuss a bit further. Okay, so let us understand what exactly a large language model is. So a large language model refers to a large general purpose language model that can be pre-trained and then fine-tuned for specific purposes. Now, focus on these 2 highlighted words, the pre-trained and the fine-tuned. We are going to talk about this in a couple of slides later. But these are 2 things that I would like you to keep in mind when thinking about large language models. You can either pre-train them or you can fine-tune them. Right? And do remember that large language models, they are general purpose models, which means that a single large language model is capable of performing various tasks. So something like a classification or a summarization or maybe some kind of information extraction. It can cater to various use cases. Let's look at where does large language models sit in the universe of so-called AI. So when you talk about artificial intelligence, there are a lot of different branches. So robotics is one, computer vision is another branch. Then within artificial intelligence, we have machine learning. So this machine learning is something which gained popularity and hype 5, 6 years ago tremendously. I mean, it was overhyped. And there are so many organizations who started, at their startups focusing specifically on services related to machine learning. And then deep learning also became very popular. So deep learning is a subset of machine learning, and natural language processing has a huge overlap between deep learning, and it also is a part of the complete machine learning ecosystem. There are few other aspects of natural language processing which I have not shown in this Venn diagram, but they come more from a statistical background and statistical studies. But what I want you to know is that natural language processing is overall a part of the artificial intelligence universe, and more closely associated to machine learning and deep learning related methods. And large language models, they are a part of natural language processing. So if you check this one small box here, it's a small element of the overall AI ecosystem, but at this stage, it is just rocking the world. People everywhere are talking about LLMs. People are trying to develop new applications. There are companies who are already using it in lots of ways that are fantastic and which were unimaginable a few years ago. So let's understand what is the core or the backbone of these large language models. So large language model, if you take the part large out of it, it leaves you with language model. So what exactly is language modeling, which is the core of all the large models? So it's a very fundamental concept in a natural language processing ecosystem, which talks about building statistical or neural network based model to understand and predict the language. So basically your language models, they look at the statistical properties and structure of your language based on the given context or the corpus that you have. And then it tries to make inferences or predictions depending on the task that you have at hand. Now, one of the most simple applications to understand uh, is this. How many of you have done a Google search? I mean, you all do it daily, but how many of you've seen this, the autocomplete feature? I'm unable to see the chat here, but guys, you can respond on the chat or you can unmute and talk. I'd be happy to keep this conversation bi-directional.
If anybody wants, they can also raise the hand. We'll allow.
Yeah, you can raise the hand or probably just unmute and talk. I'll be glad.
Yeah, Samant, you can just unmute and you can ask.
Vimlesh, do they have the ability to unmute themselves?
Yeah, they have. Yeah, Samant, you can ask your question.
Hello,
Yes.
am I audible? Sir?
Yes, you're audible.
Yes, so basically when we do the searching, it automatically completes depending on the uh, like natural language. If we have searched, it completes it by looking at the next word. It does the prediction that what could be the best possible next word for the
Correct.
given set of words.
Exactly. Yes. So this is actually what a language model does. Okay? Given a set or a sequence of words, what is the most probable next word? That is the basis and the core of a language model, and that is how every language model is trained. One of the most popular examples today for language modeling is you've got BERT and then you've got this GPT kind of architectures. But during the earlier days, a few years ago, GenSim was very popular. GenSim was widely used for language modeling and then topic modeling. How many of you have heard of GenSim? Or how many of you have worked with? Yeah, Rajgopal. Rajgopal, I can't hear you.
No, nothing. I think there was issue with my microphone. Sorry.
Oh, okay. Right. So, prior to these LLMs, Jensen was very famous for building these language models. So, the job of a language model is to predict the next word given a sequence of existing words. And the way it does is it will give you probabilities, right? So, when Google does this, it gives you a suggestion in terms of autocomplete. What it does is it runs, after you type, it runs a language model in the backend, and it gives top 5 or 6 predictions. So these are the most likely words or phrases that would occur after a given set of words, and then it will list it down all here. So I typed natural language and I got natural language processing and natural language understanding. This is something which everyone would have experienced, but the way it works is a language model is trained to give you probabilities of the next set of words. Now, as a designer of the system, you may choose to show the top 2 or the top 5 or top 10, whatever you like. But Google would normally show you 5 to 7 recommendations. All right. So what makes a large language model large? There are 2 factors. First is the extremely large size of data sets. And we are talking about data sets in terabytes and petabytes. So OpenAI, when they built GPT-3 and which was ChatGPT was built on top of it, they literally took out every piece of text that was available on the web. They used the entire data available on the internet to build their corpus, and then they trained a large language model on it. This is one of the reasons why it has knowledge of languages other than English too. So when you are building a language model, the understanding of your text comes from your corpus. And if your corpus has multiple languages, then yes, your model will have that ability to develop understanding for that specific language as well. So one is the size of the core or the source data set, and second is the large parameters. Traditionally, when you start learning machine learning, you look at algorithms like linear regression, logistic regression, or something like a support vector machine. What are the maximum number of columns that you guys have worked with? Be it a practice data set or a production grade data set. I'm curious to know if you all have done a bit of practice, and what is the maximum number of columns that you guys have worked on in the traditional machine learning approach? You can type your answers on the chat, guys. That's also fine. Use the chat. So let's talk. What is the biggest data set in terms of number of columns that you've worked on? Type your answers in the chat, guys. Let's keep this interactive. Okay. I don't want it to be a monologue. तुम लोग सब मैच देख रहे हो क्या इंडिया पाकिस्तान का? नहीं ना? Has it started, Vimlesh?
No, 2 o'clock in the afternoon.
Oh, okay. Good timing. Okay. Hey, guys. Anyone you all want to answer? We have 16 participants. Abhijit, Arjun, Arvind, Ayan. Any one of you guys? Rajesh, Sanil, Shaurya, Sham. Okay, there is 150 plus. Okay, nice. So Rajgopal has said 50 plus. Good. Yes. There are instances where you will have 50 plus. The largest when I started my journey, the data set that I worked on initially had 4 columns, but then I used one hot encoding, and all of a sudden the number of columns increased to 125. But that looked pretty huge to me back then. And then depending on the number of rows, we used to decide which algorithm to use. Do you want something that's faster to converge, or are you okay using a radial kind of kernel in SVM and allow the training process to go on? But now with large language models, there are few more answers. Web chat is disabled. Vimlesh, these
Yes,
guys
yes. We'll enable it.
that.
Yeah,
Thanks for pointing that out, Arvind. Is it done?
yes, already done.
Okay, guys, someone wants to send a test message on the chat. Okay, perfect. Thanks, Arvind. Yeah, so coming to the point, apart from the source data, these models, they work on billions of parameters. Okay, billions. So this 175 billion, this was like the GPT-3 version. Google's Palm 2 architecture, it had like close to 540 billion. There is a model called as Bloom by Hugging Face. That's over 500 billion in parameters too. So imagine you got those P1, P2. If you have the 125th column, it would be like parameter 125. But when it goes to billions and billions, that's crazy amount. And these models, they do not fit in a single machine, not at least in the current time. In future, if we have a machine that supports such a large model to fit in a single machine, I don't know, but at this stage it doesn't. So these are the two aspects which make a language model large: the size of the source data, and because you've got such a vast data, the number of parameters that you are able to fetch out of it. Now, when it comes to text, guys, what are the parameters? When you have a tabular data, you've got columns and column names. So if you want to look at a demographics data, like the name, the age, the location, the zip code, and then you have the income group, you have a probable let's say I'm looking at a real estate data set, then the type of property you're looking at, whether it's a 1 BHK or a 2 BHK. So you'll have those limited set of columns. Now, when it comes to text, what are these features? Can anyone guess and tell me? What are the features in the text? Please type it in the chat, guys. What are the features in this, text data? Yes, exactly, Shantanu. Correct. It's the words. So the number of unique words sort of become your features, and that's how they are, presented to the model. Not exactly the words, but the words are converted into embeddings. We'll talk about that as well in some time. So it's basically the number of words or the tokens that this model was able to identify from the corpus that act as your parameters. Okay, and trust me, the data set that these guys work on have trillions and trillions of tokens. So these are the two aspects that makes a large language model. This is the large component of an LLM. So I'm going to take a pause here and check if there are any questions so far before we move to how this all started. No questions? Shall we proceed then? Okay, so let's start with understanding how this all started. How did our universe come into existence, guys? Can anyone tell me? You've heard of this Big Bang theory? Who's heard of Big Bang Theory? Yeah. So, Earth came into existence because of a Big Bang and an explosion, and that led to formation of our planet. So it was somewhat a similar story with LLMs. So the Big Bang for LLMs was the Transformers architecture. So deep learning had become very famous by then in 2017, and people were using different kind of architectures like CNNs and RNNs, and then LSTMs came into picture, by LSTMs came into picture, and there was a lot happening around that. And then all of a sudden, this paper was released on Transformers. It said, attention is all you need. You can look at the paper. I'm going to type it for you. Yeah, that's right, I am. Attention is all you need. This is the paper. You guys can look it up. And that explained, what the transformer architecture is, and, what are its components, and how it uses something called as attention masks. So that was a pretty interesting architecture. And this was, primarily designed to tackle the use case of translation. So it all started with understanding how can translation be done better, because Google was way deep into offering translation services back then, and they really wanted to improve it, because when you translate from one language to another, the sequence, or rather the structure of the language changes, because grammar is not same for every language. So in English, if you say I play football, in Hindi it would be मैं football खेलता हूँ. So your subject, object, verb, the order changes from English to Hindi. And transformers were built so that you could have special attention to the words that require attention, and the ones that don't really require attention should not be offered that special attention. And the weights varied accordingly. And after that, after introduction to transformers in 2017, the very first version of GPT, the generative pre-trained, that paper was launched in 2018. And a few months after that, BERT was introduced. So BERT was another architecture built on top of transformers. So BERT, the major use case of BERT was summarization, but it was also equally used for translation related use cases. And GPT was purely a generative model. Its job was to generate text. So that's when I would say the generative AI thing started, or rather the revolution in the generative AI started with introduction to GPT. This was very, very first model, or I would say the idea that they had in their minds came into existence. And now let's look at the overall evolution. So this yellow curve that you see, this is pre-neural network era, you could say. So you had these typical statistical models like ELIZA, and during the 80s and 90s, there were many other statistical advancements made. You had hidden Markov models, and you have n-gram models. And then in 2000s, in later 2000, neural probabilistic linguistic models, again, a combination of deep learning and statistical techniques. Then in 2013, this was a very important breakthrough when word-to-vec was introduced. So this introduced the concept of word embedding. So that's basically converting your word into dense vectors. And that really was a groundbreaking change for all the NLP applications. Because with that, you were able to understand how similar two sentences are and how dissimilar they are. And in word-to-vec, they did some kind of equation, man plus king minus woman, and that led to queen. So they were able to do all that kind of arithmetic on top of that. But the practical use case of word-to-vec was to utilize these embeddings for practical use cases like text classification or token classification. Token classification is also called NER, name entity recognition. So after 2013, things picked up in NLP. And then in 2017, you had the transformers models and the attention mechanism. 2018, BERT came into picture along with GPT-1. 2019 was the era of GPT-2 and T5. T5, by the way, is a model from Salesforce that is also open source. I have personally built a model on top of Code T5. So Code T5 is a large language model trained on 6 languages, programming languages. And I've built an open source model. You feed in a Python code and it is going to give you an explanation of that code. So that's available on Hugging Face. I'll share the link later on. But T5 was primarily trained not only on the programming languages, but also natural languages. And then come 2020, this is where GPT-3 came into picture. And after that, things really went crazy after the introduction of GPT-3. So this bright red was really the time when everything got so hyped and people got all charged up and excited. And after that you had the Lambda, the X Large, the CodeGen, the MGPT, Google's Palm 1, the OPT, a lot of different variants came out. So you could truly say that this 2017 and 18 was like the birth of the large language models, and GPT-3, the 2020s, the late 2020s is when it actually started gaining a lot of attention. And in this entire duration, there were a lot of organizations that were built whose use cases were in and around large language models, not necessarily generative AI, but utilizing large language models in some or the other way. So November 2022 is when ChatGPT came into existence. So that's when, OpenAI's fortunes also turned. Microsoft had that investment in them as well. And immediately, month or two later, they released ChatGPT 3.5. So this was a more stable version in terms of the responses it offered. Then in Jan 2023, there was a WebGPT, an open source project trying to provide open source alternatives to GPT, because ChatGPT 3.5 is available for free. However, it is still proprietary in nature and it is not true open source. And then GPT-4, as you all know, is either a $20 a month service or you have to pay for the API. And then in Feb 2023, Google released Bard and Meta released Llama. So Bard is still available for you to use, free of cost as of now. It is still in some kind of an experimentation, and there are a lot of changes happening in the Bard. The outcome of Bard is not as effective as OpenAI based on my personal experience. Again, please do your own research. But the outcome it generates, the natural language it generates for the responses are not as good as OpenAI. But at the same time, from whatever I tested, Bard gives you comparatively predictable responses. Okay. Now Google is working on Bard 2, which is built on top of Palm 2 architecture. So I'm not sure when that would be released. But again, Llama was another game changer. So initially, Llama was introduced as a research-only model. So these were alternatives to ChatGPT. People were in awe. People wanted to build, have the ChatGPT-like capabilities, but there were concerns around privacy, concerns around security. So they wanted to understand if there is something which can be done in-house, even on a smaller scale with less parameters. So Llama 1 was introduced, and Meta took a huge step here. But this was like an academic research project only. Commercial usage was not allowed. Then enter 2023, GPT-4 was released. And after that, 2023, Bloomberg GPT, Stable LM, Dolly 2, Titan, Big Chat, Llama 2 as well, that is out. And these are all open source models which can also be used commercially. Many of them can be used commercially. Okay, so Llama 2 is one of them. Llama 2 was one of the groundbreaking changes in the open source universe that allowed people to use it commercially. And after that, there were several others like MPT from Mosaic and most recently Mistral AI 7 billion is also gaining a lot of popularity. That is also open source and available for commercial use. So we've come a long way, and in fact now ChatGPT even has a multimodal capability. How many of you have read about that? The multimodal capability? Hey Rajesh, I'll come to your question in a while. Yes, Aman, go ahead.
So there is a question like when in the second or third slide when you showed that you have written natural language and Google has already predicted processing and understanding. So this is a prediction that on the natural language 2 words it has predicted the third word that it might be this. And when we talk about text generation, that also depends on the prediction itself.
Yes.
It is like previous 2 words or 3 words, it sees and assign the weights, and according to that weights, it will tell that this might be the next word. So what is the actual difference between this prediction and that generation?
So this prediction, this thing that you see is purely a language model based on a neural network, and it is unidirectional in nature. Okay. So we're going to talk more about it in the upcoming slides, but I'm giving you an idea. This is unidirectional in nature. If you don't type anything, it might probably give you recommendation on recent suggestions based on your browsing history. But if you type 2 or 3 characters, that is when it will be able to make a suggestion. So it always works in one direction. You type first, and only based on the existing context, it will be able to give you what do you say, the next set of probabilistic words. The generative AI use case, on the other hand, you give it a topic. So let's say you give things to ChatGPT like write an email template for me, um, seeking time with the client for a demonstration. So it's going to generate that entire template. So you're not typing the template or a part of the template first and then it auto completes. No, you just give it an instruction. It understands the instruction and generates the entire text. So that's the core difference between the sequential predictions of a language model and the generative capabilities. Does that clarify?
Yes, sir.
Yeah, Rajesh. So, BERT GPT, good one. I'll share the links of all those. So, BERT was essentially a Google project. Transformers also, started all the way back with Google research. GPT, I guess, these OpenAI guys, they were experimenting with GPT long way back. All these papers, they are available on Hugging Face. I'm going to walk you guys through the Hugging Face hub also and let you know why is it important to keep yourself familiar with it, because there are a lot of changes. So if you talk about the current number of models that are available on Hugging Face, Hugging Face, by the way, is an ecosystem where people host all kinds of models that they build, small to large. All the models are available on Hugging Face for you to use. So they've got over 350,000 models available, and it's huge. Trust me, it really is huge. Okay, so this was a bit about the evolution, and I've taken this image from a very nice blog by Armin Norozi. So I've shared the link with you guys as well. I'll be sharing this PPT at the end of the session. Please do take a look at the blog. He's talking about the evolution very nicely over there. Okay. Now, coming to the 2 words that were highlighted in the beginning, the pre-training and the fine-tuning. So let us first understand what is a pre-training. So pre-training in LLM is basically an act of training a language model from the scratch. So it's like training any model from the scratch. The weights that are assigned are initially randomized, and then the training starts without a prior knowledge. So basically, if you have to, retrain GPT-3 from the scratch, you'll have to take all the internet data, start with the base architecture. You'll have that extremely large corpus, and here instead of days, assume you're going to have months of training, and you'll have to spend close to 1.5 to 2 million. I think it's less. It should be more, close to 10 million in compute costs, and that will give you your pre-trained large language model. Okay, so pre-training is basically an approach that we guys have been taking traditionally for any machine learning project. You have a set of data or corpus that is proprietary, and we start building or training our model from the scratch using that data set. We can do feature engineering, we can do a bit of feature selection, some fine tuning, data cleansing, but again, we always rebuild model from the scratch. How many of you have done this? Yeah, Rajesh, I'll show all the tools that are available. It's there in the further slides. Do you mind waiting for those slides, or you want to see some of them now? Okay, Rajesh? Okay. Please type in your answer in the chat. Guys, my question is, how many of you have experienced this? Whenever you are working on a typical machine learning use case, you always have to start your training from the scratch. Yeah, exactly. I am. So even after working on that feature engineering, and once things are ready, you have to. So there is another question that we have. What are the channels where someone like me who has no real life experience with AI can learn the trades of AI while working, if not necessarily paid, on a real-time industrial projects? Yes, I'm going to come to that. When we look at the Hugging Face ecosystem, you will get clarity to your question, because you can not only learn, you can also practice, and you can keep up pace with what's happening in the industry. Yeah, Rajesh, we're going to come to that in a while. I know you're all very excited to look at the latest tools that you can use immediately, and I'm going to share some very exciting tools with you guys. Okay, so this is the idea of pre-training an LLM, which of course is very time consuming and extremely costly. So there are different kind of pre-training methods. One is an auto-regressive method of pre-training. So this is typically your Jensen kind of a use case. So they are normally left to right kind of model. So the way these models work is they will only look at context to their left and try to predict the next word. So this is how the what do you say, auto-regressive model works. So the first version of GPT and then Eleuther AI's GPT Neo and GPT-J, they were pre-trained based on this method. Then there is a masked language model. So what this does is it looks at context in both the directions. Auto-regressive looks at your context only in one direction, from left to right. So Samant, again, this is similar to what you were asking in the past. But natural language, it predicted processing. But if you don't have a natural language, it cannot predict processing. Masked language models, on the other hand, they are context aware in terms of bidirection. Okay, they will look at the context before and after, and that's why the overall awareness of context it enhances. So BERT had made one change to the transformer architecture, was going bidirectional by using the masked language models. And then you have the encoder decoder kind of models. So these are also called as sequence to sequence models. So typically use cases like English to French or Hindi to English, those kind of translation tasks, or speech to text, they use this typical encoder decoder models. So code T5 is one of them, which means you are given a piece of code and then you can generate an explanation or a summary of the code from that. Sorry. So these are some of the pre-training approaches that can be taken. And then let's understand the difference between pre-training and fine-tuning. In pre-training, you start from scratch. However, in fine-tuning, you already pick up a model that is pre-trained on a large corpus, which means you do not have to spend time on training everything from the scratch and creating, that model from the scratch. So one of the benefits of using a pre-trained model is its context awareness, because it is already trained on a large data set. There are a lot of possibilities that it will coincide with the kind of data set that you have. So you can do the fine tuning job on a single CPU and the results are easily reproducible. The compute cost is less, overall time taken is also less, and then you get a fine-tuned language model which is adaptable for your own specific task. And the way fine-tuning works is, it all started with transfer learning, where basically you pick up weights from one model and then just fine-tune the last layer of your neural network to make it adaptable for your specific use case. So imagine you have a sentiment classifier that is trained on Twitter data, and you have your own company's reviews data lying somewhere in the database. If you were an e-commerce platform and you wanted to do sentiment analysis on your own data, what you could do is simply take a model that is capable of doing sentiment analysis and fine tune it on your data. So that way, with limited examples and smaller data set, you would be able to get a very good performance. Then there is something called as a task specific fine tuning. So you have these base models which are already pre-trained. Now, if you want to create a model that is able to generate summary or a model that is able to translate, you can create additional layer which is specific to the task. We call this heads. Okay, these heads basically fine tune your model to perform a specific task. Now, this is more time consuming as compared to a transfer learning, because this use case may have to be built from the scratch. So you would require more training examples. But yes, again, you do not require to build the pre-trained base model. You will still be fine tuning it. And then there is this concept which has come more recently called as adaptive fine tuning. What it basically does is it adapts the learning rate like you see in your gradient descent. But here, since there are a lot of parameters and multiple GPUs and CPUs involved during training, the adaptation becomes a bit difficult as compared to a normal process. So the learning rate is changed dynamically in order to achieve faster convergence. All right. So the question is, then why fine tune and not just pre-train a model from the scratch? We've already discussed the answers, but I'm going to summarize it for you. See, fine tuning allows you to take advantage of the knowledge acquired by the model during the pre-training phase. You don't have to retrain on that vast context again. And since the pre-trained model has already seen a lot of data, the time taken for you to converge your fine-tuned model is going to be lesser. And even with limited and smaller examples, you will get decent result. So these are the three major benefits of fine-tuning. Some of your hand is still raised. Is it that you raised it again for a question, or was it for the last question you asked? Come on. All right, so now I'm going to switch over my screen. Give me a moment. I am pausing the screen share. I'm going to stop the screen share. I'm going to share a different screen, guys. I want us to look at, just a moment, guys. Okay, guys, can you see this screen now? The Hugging Face screen.
Yes.
Okay. So this, this entire ecosystem of Hugging Face has become extremely popular. So Rajgopal, to your question about, where to look for models. If you go to Hugging Face and click on models, you will find models for every single use case that you like. So I'm not going to talk about multimodal right now, but let's say if you're working on computer vision, so image classification or object detection. So these use cases are already here. Video classification is one. For natural language processing, things like text classification or a token classification, question answering system, summarization, conversational. This is basically your chat kind of systems. Text generation, sentence similarity, text to text generation. Every use case that people are working on, you will find some or the other model. So if you were to look at, let's say, text classification, you click on this, it is close to 33,500 models just for text classifications. And this is a Roberta-based architecture for detecting emotions. Okay, so this guy said, I'm not having a great day. And it is giving probabilities of whether it is disappointment, sadness. It's giving all the probabilities here. So the probability of disappointment and sadness seems to be pretty high as compared to if you look at joy and anger, it's like very, very low probability. So these models, you can use them readily. Okay. If you just see, use them in transformers, it's going to show you how to use them. You can use this model readily or just fine tune them. You'll have the model documentation and you'll also have the learning resources. Now, if you want to use this somewhere, there is this option of deploy. You can create an inference API using the same model, or let's assume you fine tune this model and you uploaded it on Hugging Face. You can use the inference API provided by Hugging Face. So what it does is it lets you host a model on their ecosystem. It will give you an API. Users can ping and get response. Or it can create inference endpoints using SageMaker as well. It also has integration with Azure ML now. But yes, there are several options available for you to deploy. And Spaces is one thing that I'm going to come to in a while. It lets you demonstrate your capabilities. I think there is a question. Hold on. So Teja, prerequisites to start working on LLMs first. See, if you really want to fine tune an LLM and use programming and make those granular changes, get good with Python programming, get good at understanding deep learning, get some familiarity on PyTorch, understand the transformers architecture, and most importantly, go through this Hugging Face course. So Hugging Face has this course. You can click on learn and you can learn the NLP course from here. So this basically gives you an overview. It only teaches you about Hugging Face ecosystem, but I think it's a very solid tutorial. It's available free of cost. So this is where you should get started. Okay, so yes, coming back to the deployment thing. So it is pretty easy to deploy using this. And then obviously you can, set that how do you want to scale up or scale down basis of this. And then I was talking about Spaces. You can also use Spaces. So Spaces is basically a way for you to showcase what are you doing or what your model does. I'm gonna try this. Let's say Zephyr chat. Someone has done a chat space. So 1 second. There is one more question. It seems in the chat. Are models deployed here free of cost by using API? So they've got a free account as well as a pro version. So there is a charge for the pro version. The free account will allow you to, I think inference API is a part of the paid version, but using the free, what you can do is you can upload your model there. And then people can just test it on your models page. There wouldn't be like an inference API on that. So here it's just a demonstration of the chat or so. But you know what? We can check the inference if there are any changes to inferences. Yeah, so the inference API. Okay, for there is a free evaluation available, but for your production use cases, you'll definitely have to go for the paid ones. It can come with some limitations. You can try that. So if you use a model, these are open source model. People will not charge you for the models. You fine tune a model for yourself, and then you can upload it here for inference. And that is normally how people work. Okay, I'm gonna come back to the presentation. So yeah, that was a note about fine tuning of applications, fine tuning of your models. Now let us understand where are LLMs popularly used. So we've looked at cases like translation. There are chatbots. So ChatGPT is a very popular example. Content creation. So ChatGPT can also do content creation apart from just having a human-like conversation. So if you ask it to write a blog or write an email, it can do that. It can even write poems. Code assistance. Code assistance is also a very popular use case. GitHub Copilot is an example of code assistance. AWS is something called as Code Guru. So they kind of give you analysis and also predict what the next set of your programming language code would be. Tab9 is one example. Then there is this concept called as RAG. It is called retrieval augmented generation. So a lot of companies are building their use cases around this. So it's like building your own private chat GPT for your knowledge base, for your internal company data. And then you've got transcription. So this is basically converting your text into audio or audio into text, either ways. So these are some of the popular, and there are a lot other applications. So if you simply go to Hugging Face and look at this models ecosystem, these are all the use cases that you'll come across. So this is what happens. You can explore every use case one by one. I've only picked up some interesting ones here for the sake of displaying. And how we are using LLMs in Invent Health. So these are all prototyping stage at the moment, all the models here. So we are using generative capabilities to generate email templates for our clients. So our clients are insurance companies who have medical coders, and sometimes when they want to interact or ask queries to the doctors or the hospitals who send the claim forms, they typically follow, like a template or a format, but they want it auto-generated based on specific use cases for a clinical note they look at. Second is a Q&A kind of question. So basically, there are important details that medical coders look at, like what is the blood pressure, what is the BMI, and questions related to other vitals. So we're trying to build a Q&A system around that. And the third prototype that we're working on is natural language to SQL. So our clients demand a lot of report from us. And what we thought is, why not build a model that can translate natural language into SQL queries? There are a lot of options available now that can, work on this specific kind of use case. So we basically take the natural language input, generate a SQL query, and based on that SQL query, we run it against the database and give the output as a table. Okay, so a quick test. How many of you know what these companies are? So this is Hugging Face, the one that we saw here. It has a lot of support for open source and free projects. It also has its own paid services. Inference endpoint is one, private model hub is one, and I'm going to show you one of those. So there is this concept called as auto train that I wanted to show you. I think it should be, yeah. Solutions. You've got this enterprise hub, and then there is this auto train. So this is really a fantastic project, guys. So all you need to do is upload your data. So let's say you want to do sentiment analysis. You just need your data and with the columns in it, review and sentiment. So Hugging Face will automatically select the top 3 or 4 models from its hub that it feels will generate the best outcome for you. It's going to train all those models parallelly and then finally select the one model that gives the best result and it lets you deploy it. So with auto train, basically, you don't even need to know Python or understand this entire thing. If you have the data, you can use auto train. You should know your business use case and you can create a machine learning model out of it. So this is, yeah. There are many tools based on RAG. I'll talk about one right now. That's in the next slide. But do keep an eye on this auto train, guys, and it's pretty helpful. So see, Hugging Face is a combination of open source, free, and paid sort of offerings. OpenAI, ChatGPT free version is available, and rest of the other APIs are paid. Same thing with Anthropic and Cohere. So OpenAI, Anthropic, and Cohere, they go head to head. They all have same kind of offerings. The only differentiator here with Anthropic is OpenAI has a limit of 16,000 tokens for GPT 3.5 and 32,000 for GPT 4. Anthropic's LLM is called as Claude 2. It has token length acceptance of 100,000 tokens. So 1 lakh tokens is like, I don't know, 70 pages. It's like one entire sort of small book. And apart from that, these are the players who are doing a lot of open source contribution. Hugging Face is one. LangChain. So for retrieval augmented generation, people usually use LangChain. So LangChain will basically allow you to connect to OpenAI or some other model that is available on Hugging Face Hub. And it can generate question and answers based on your private knowledge. Then Mosaic ML has open sourced a couple of other models. So these are companies that are doing work in open source space as well. So these are basically an overview of the kind of use cases that you will have around LLMs or the organizations that are coming up. So one is the API service providers. So companies like OpenAI, ChatGPT 4 or Monster API. So Monster API basically lets you host any other open source LLM, just like Hugging Face inference points, and you can pay them per token. Then there are core infrastructure providers like Azure or even Hugging Face, who's also allowing you to auto train. And then there are wrapper-based products. So there is this company called as Right Sonic. So that is, it does retrieval augmented generation. So Right Sonic basically allows you to upload documents and then you can ask questions and answer questions about your documents and it answers them. It has a lot of other use cases too, but you can look at Right Sonic as one of the use cases. And special mention, this is due to retrieval augmented generation. Vector databases have risen a lot. So every word or token that you have in your natural language is first converted into a vector. And vector is nothing but a dense array of numbers. So in order to save or store these vectors, now vector databases have come up. So previously, Lucene or Elasticsearch was very popular for these kind of use cases. But now these vector databases have come up with purpose-built databases to support vector operations on vectors for text or image or videos. So Pinecone is very famous provider of vector database, and vector databases are heavily used in retrieval augmented generation. So basically the data that you upload is vectorized and saved in a vector database. So when you ask a question, it queries the vector database, fetches the answer, and it is sent to an LLM that can generate a response or beautify the text, and the response is sent back to you. So this is how your retrieval augmented generation works. And after all these things, Munda and Circuit are also thinking कि अपन को भी LLM बनाने का. But yeah, LLMs come with their own challenges as well. So if you are unaware about how to work on distributed training and inference, or retraining frequency is a big challenge, because you cannot keep pre-training a model so big very often. The reliability and consistency which you guys have experienced in terms of ChatGPT, now the answers have become a bit more predictable, but the quality has dipped. And then these models, they can hallucinate, they can make up answers and confidently lie. And beyond technical challenges, you've got things like the data quality and bias, the control and the governance, data privacy concern, and shortage of GPUs. So there are still challenges, but a lot of people are working around this. I'll come to this slide in the end. But what lies ahead is there are a lot of open source models which are not necessarily as big as ChatGPT and the GPT-4 are, which will allow you to work on your proprietary data. And faster and specialized kernels and inference servers are available for on-premise deployment. So you may train on GPU, but you'll be able to make fast predictions on CPUs. And multimodal is where people are heading right now. So combining text and audio and video and sound, combining all these modalities and giving outcome, that is where the world is heading. And this is one experiment that we had run. So one of the use cases that we are working on is a name entity recognition. I have a working example for you guys. So I have fine-tuned this model. Okay, so this model is available on Hugging Face. It identifies the problems and treatments. I fine-tuned it for my specific use case to identify certain entities, clinical entities. So basically, the cost benefit ratio of using a smaller NER model versus using something like an OpenAI's GPT-4, the cost benefit ratio was clearly not there. So time for training 10,000 pages was 1 hour for the smaller model versus 4 hours. Cost was $3 for the smaller model. My inference time was 10 minutes against 1 hour. Cost of inference was pretty low. Accuracy, nearly the same. So if you have a use case that can be solved with smaller task-specific focus models, don't go for LLMs. Use LLMs only when they are needed because of the challenges that they come with. Okay, so that is an important fact that I wanted to stress on. But LLMs are becoming more accessible and usable. There are several techniques like PEFT, which is called as parameter efficient fine-tuning, quantization to reduce the model size. Adapters is to just add a layer and only fine-tune that layer for quicker training, but inference is again going to be costly. Specialized kernels, no-code training, like we saw, Hugging Face, and inference servers will all be available for you guys. So yeah, pretty interesting times ahead. Q&A with the human. I'm sorry we are 3 minutes over the scheduled time, but I'm open to take any questions if you guys have, or if you want to discuss or share anything with the community.
Uh, Feel free to ask question, guys. If there is no more questions, Sagar.
No questions? Okay. So I guess any platform that guardrails. So see, guardrails is one that monitors the outcome. You can use that, but when it comes to data privacy, that will have to be handled by you. And data privacy is more of an engineering problem. It's about how you store and save the user data. You have to make sure that your data is encrypted at rest and it is also encrypted in transit. You have to make sure you anonymize your data as well if you want to maintain privacy. PII should never even be a part of your training. You can use dummy names, anonymize everything, but that will have to be handled separately.
Great. Any more questions? I think we are also running out of time.
All right. So thank you so much, guys, for joining on a weekend. And good luck for your future endeavors and all the best for the match as well today. Let's hope for a big win. If you guys want to get in touch with me, you can connect with me on LinkedIn and feel free to ask questions over there if needed. But it was great talking to you guys today. And I wish you a wonderful weekend ahead.
Thank you, Sagar. Thanks for taking out your time.
Just one question. Can you elaborate when not to use LLM? It's a cost-benefit ratio. When let's say you've got similar accuracy, small model and LLM. So in our case, the accuracy was 91% approximately, LLM at 91.5. But the cost of prediction for an LLM is extremely high, and the cost of prediction for your smaller models is going to be pretty low. So when your performance can be at par and the cost benefit ratio does not match, you should avoid using LLMs. And especially high latency use cases, when you want like a real-time answer, at this stage LLMs might not really work.
Great. All right. Once again, thank you everyone for taking out your time and joining us. One more question coming.
Yeah. For NER tagging, use a bird-based uncased. That's what I use for NER. It works pretty well.
So, all right, guys, if you have more questions, you can join our community. I just posted our community link. So feel free to ask any of your questions. So we'll, hope we'll try to address all of your questions. And once again, thank you, Sagar, for taking out your time, joining us on this Saturday. I know it's a long. I mean, it's a weekend, and we have India-Pakistan match also. All are excited in the afternoon. And again, we'll see you on the next week in the different topic. Till that, have a great weekend. Take care and stay safe. Thanks, Sagar. Take care. Have a wonderful weekend.